Welcome. In this explainer, we're going to break down the absolutely critical design thinking behind service graphs in a Cisco ACI multi-pod fabric. This is all about how you intelligently slide services, like firewalls and load balancers, right into a network that's spread out over different locations. So, here's what we're going to cover. We'll kick things off with the basics of what service graphs mean in a multi-pod setup. Then we'll get into the super important high availability models. And after that, we'll do a deep dive into 3 real-world scenarios: the transparent firewall, the routed firewall, and the more modern kid on the block, policy-based redirect.
All right, first things first, let's build a solid foundation. Why do we even need service graphs in a multi-pod world? What problem are they actually solving for us in a big distributed network like this one?
Okay, at its heart, a service graph in ACI is basically a super smart way to steer your traffic. Instead of getting bogged down messing with complex routing tables, we get to use policies, ACI calls them contracts, to just automatically insert services exactly where we need them. And as you can see here, this works for north-south traffic, that's stuff coming in from the outside world, and for east-west traffic, which is all the communication happening inside our application, say between a web server and an app server. So this really boils down to 3 main ways you'll see this used. Number 1 is that classic perimeter firewall for your north-south traffic. Number 2 is securing that internal east-west traffic within the same logical network, or VRF. Think of that as putting a guard between your application tiers. And then number 3 is using a firewall as a central checkpoint for any traffic trying to move between different VRFs entirely.
Okay, so putting a service in the path is one thing. But what happens if that service, or hey, even the entire data center pod it's sitting in, has a really bad day? We can't have that. We need our network to be resilient. And that's where high availability design becomes absolutely essential.
Well, ACI multipod gives you a few different options for high availability. You could have active-active clusters or totally separate pairs in each pod. But for this explainer, we're really going to zero in on a very common and very effective design, the active standby pair that's stretched across 2 different pods.
All right, time for our first deep dive. Let's take a look at how we insert a transparent, or what we call a layer 2 firewall between our pods. This is a really popular design, especially when you want to add security without having to completely re-IP or change the routing of your network.
You gotta love the name for this one, the bridge domain sandwich. And this diagram shows the trick perfectly. To make a transparent firewall work, ACI does something really clever. See how the web EPG is in bridge domain 2, but its actual default gateway IP is in bridge domain 1? It's that little bit of misalignment that forces any traffic that needs to leave its subnet to first go through our layer 2 firewall. Pretty slick, right? Now for this whole stretched active standby thing to actually work, the fabric has to do something called hairpinning. And don't let the name scare you. It's pretty simple. It just means that no matter where a packet starts its journey, the ACI fabric is smart enough to detour it across the inter-pod network to wherever the active firewall is hanging out at that moment.
Okay, let's follow the packet, right? Look at that blue line. Traffic comes in from the outside world, the WAN, and it hits our network in pod 2. But the active firewall is all the way over in pod 1. So what happens? The fabric does its magic, hairpinning that traffic across the inter-pod network to the active firewall. Only after it gets inspected and approved does it finally get sent to its destination, Web VM 1.
Let's switch gears and move on to our second major design pattern. This time, we're not just kind of sneaking a firewall in at layer 2. Nope. We're making it a full-blown layer 3 hop in the network path. We're actually routing traffic through it.
The thinking here is similar, but we're moving up the stack to layer 3. And this time, we're using, you guessed it, a VRF sandwich. Check it out on the diagram. The web EPG is in that orange VRF2, but the connection to the outside world is in the blue VRF1. By sticking our firewall right in the middle of these 2 VRFs, we absolutely guarantee that all traffic has to pass through it to get routed from one to the other.
So how does this play out across pods? Well, imagine Web VM 2 over in pod 2 wants to talk to the internet. The local leaf switches in pod 2 know the only path out is through the firewall, and they've learned from the fabric that the active firewall is in pod 1. So that traffic gets bounced, it's really another word for hairpinning, all the way over to pod 1, gets inspected, and then it's sent on its way.
And when it comes to actually cabling this thing up, you basically got 2 choices. On the left, you see a virtual port channel, a VPC, which connects the firewall to 2 different leaf switches. That's for maximum redundancy, and it's definitely the preferred way, but it does require some specific hardware. On the right is a simpler setup, just connecting to a single leaf. It's more universally compatible, but you do give up a bit of that physical redundancy.
And the really cool thing is, this same routed concept works beautifully for that east-west traffic too.
The logical design is almost a carbon copy, but instead of sitting between an EPG and the outside world, now the firewall is sandwiched right between two of our internal application tiers, like the Web EPG in VRF1 and the App EPG in VRF2.
Now, you really have to watch the traffic flow here, because it's not always symmetrical. This is super important. Follow the brown line. That's traffic from App VM2 in Pod 2. It has to get bounced across the network to the active firewall over in Pod 1. But now, look at the return traffic, that yellow line. Traffic from Web VM1 in Pod 1 goes to its local active firewall, and then it can go straight across to App VM2. So you see, one path is bounced, but the other is direct. All right, on to our final scenario. Let's talk about a more flexible, and you could say more modern, way to handle all of this. It's a method that can really simplify your configuration. Policy-based redirect, or PBR. And right off the bat, here's the #1 thing you have to remember about PBR in ACI. This is huge. Unlike those other two scenarios where a service graph was kind of optional, if you want to use PBR for service insertion in ACI, you must configure a service graph. It is a non-negotiable requirement for this design. So why bother? Simplicity. It's all about making your life easier. Take a look at the diagram. Remember that VRF sandwich we just talked about? Gone. With PBR, the external connection, the firewall, and the Web EPG can all live together happily in the same VRF. We're not playing games with routing anymore. We just create a policy that says, hey, if traffic matches this contract, just redirect it to the firewall. It's so much cleaner.
Let's see this in action. A packet leaves Web VM1 and heads to its local leaf switch. Now, normally that switch would just look up a route. But because it has a PBR policy, it does something different. It says, whoa, hold on, and it redirects that packet over to the active firewall in Pod 1 for a security check. Once the firewall says it's all good, it sends it back to the fabric to be routed out. It's a really elegant, policy-driven design.
But nothing's perfect, right? There's a trade-off here, a gotcha, you really need to be aware of, especially with that east-west traffic. In some cases, specifically when your source and destination are in a different pod from the active firewall, PBR can actually cause your traffic to hairpin across the intrapod network twice. And that can have a pretty big impact on performance, so it's something you definitely need to plan for.
All right, let's pull it all together. The big takeaway is that service graphs are your best friend for smart traffic steering in ACI multipod. We've walked through the three main design patterns: the Layer 2 transparent firewall, the Layer 3 routed firewall, and the modern PBR approach. We also learned that for any kind of stretched HA, hairpinning is the secret sauce that makes it all work, and that each of these designs has its own unique traffic flows you got to consider.
And that brings us to the final question, the one you have to answer as the architect. Now that you've seen the patterns, which model is the right fit for you? Do you go with the simplicity of the transparent design, the absolute routing control of the routed model, or the modern flexibility of PBR, even with that potential for a double hairpin? The right choice really depends on your specific needs for availability and performance.